This lesson is on 6.4, which is similar and congruent figures. So some of the vocabulary we should review are what are similar figures. Similar figures are two figures which are similar figures if they have the same shape, but they're not necessarily the same size. So you could have a square that's really large and takes up the whole page, or you could have a small one, and those are going to be congruent. It doesn't have to be a square. It could also be triangles, and they'd have to have the same angles and have the same shape, but not the same size. Corresponding parts of figures are sides or angles that have the same relative position. So if we had a triangle like this and a triangle like this, we may say that side A corresponds to side D, while B is E and C is F. Sometimes this is denoted by putting a line through it. So A to B is congruent to F to D. And here we may say A to C, put two lines, just like C to F. Could also be the angle. So we could say angle A is congruent to angle D. And congruent figures, or two figures are congruent if they have the same shape and size. So that's not only, they can't just be similar, they have to be exactly the same shape and size. So let's go over some properties of similar figures. So when we name a triangle or a shape that are similar, we list the letters of their corresponding vertices or angles in the same order as they are in the diagram. So in this case, we say triangle ABC is similar to DEF. We put these letters in the right order so they match up. So we know A and D are the same angle on these similar figures, and B and E and C and F. So we can come up with two things. They have corresponding angles of similar figures are congruent because the angles are going to be equal. So here we use these double lines or single line or right angle to show that, but we would write an angle using this symbol, right? It looks like an angle. We use this as a triangle, but angle is similar to, angle A is similar to angle D. So this little squiggly says that they're similar, and the equal is that they're congruent. So here they're similar and equal for the angles. Now, when we do the length of a side, which is different, so we're talking about from A to B, is the same thing as D to E. So the ratio of A to B to D to E, so 8 to 4, is the same thing as B to C, E to F, and A to C, E to F. They all equal 1/2. So we can use our ratios to figure out how does the size of this figure compared to the size of this. And in this case, this is double the size, because each side is double the length of the smaller one. This will become more clear as we do some problems. So example 1, identifying corresponding parts of similar figures. So if you're given a triangle ABC is similar to triangle DEF, you can name the corresponding angles and the corresponding sides without even seeing the triangle, because we know that they're written in the order that correspond to one another. So we know angle A is similar to angle D, B is similar and corresponding to E, and C corresponds to F. And corresponding sides is the same way. AB is the same as DE. BC is the same as EF. And CA, or AC, is the same as DF. So what I'd like you to do is try that for the shape below. So it doesn't matter that this has more than 3 sides because the rules still apply. So in this case, the first corresponding angle would be J corresponds to Q. So go ahead and give that a try. Press pause now. So here in example 2, if you are again given two shapes and you have to find the ratio of the corresponding side lengths. So it gets a little sloppy here, but we're given that ABCDEF is similar to GHJKLM. Find the ratio of the lengths of the corresponding sides of A, B, C, D, E, F to J, H, J, K, L, M, N. So this. In this case, we can say we know that the corresponding sides will all have the same ratio. So A to B is 6, G to H is 2. So our ratio is 3 to 1. We can prove that this works another way. So we can say, let's try C to D, which is corresponds to, so this corresponds to J to K. So C to D is 5.1. J to K is 3.6. And you can plug that into your calculator and you'll find, okay, just checking, I actually made a typo. I accidentally wrote 3.6 here, but I looked back at the figure and it should be 1.7 corresponding to J to K. So we're just going to make that change. So in this case, 5.1 divided by 1.7 is 3. You could also try, if you don't believe me, B to C over H to J. So B to C is 2.7 divided by 0.9 also equals 3 to 1. So we can see no matter what side you pick, because they're similar, that you're going to be able to use this ratio to find the length of any side. So if I hadn't given you one of the sides, you would have been able to figure it out. That leads us to our next problem. So checking for similarity. So you have to tell whether the triangles are similar. So we're not sure, but in this case, these lines are telling us, this line here tells us that it's equal to and congruent and similar to this angle. And this with the 3 lines corresponds to this. So we know that A matches up with J, B matches up with K, and C matches up with L. So the corresponding angles are congruent. To decide if the triangles are similar, determine whether the ratios of their lengths of the corresponding sides are equal. So we need to figure out if the A to B is equivalent to J to K. The ratio of that, is that the same as the B to C, K to L ratio, and the A to C, L to J ratio? So what we can do is we need to figure out if these ratios are equal. So we can plug the numbers in for each of the sides, making sure that we keep the first triangle on top, the second triangle on the bottom, and then figure out when you divide 5 by 8, you get 0.625, and so on. If they're all equal, then yes, they are similar. If they weren't all equal, then that means they're not similar triangles. So I want you to try the following. So the corresponding angles are congruent, and the ratio of the lengths of the corresponding sides are equal. So triangle ABC is similar to the triangle JKL. I'm sorry, this was just the summary for this, not a problem for you to try yet. So yes, they're similar. So example 4 is finding measures of congruent figures. So what if we didn't know all the side lengths? And what if we didn't know all the angles? Would we be able to figure that out if we knew 2 figures are congruent? So congruent means that they're exactly the same figure. They have exactly the same size and exactly the same shape. So the length of G to H, what is that? Well, we can look at the figure below, and we know G to H is equivalent to P to Q, so it has to be 4 inches. And here, the measurement of angle K, we don't know it here, but we know from up here that K matches up with S. So if we can read angle S, which looks like 64.7, we can say K is congruent and similar to S, so it's 64.7 degrees. So I want you to try one on your own and tell whether these 2 rectangles are similar. And if they are similar, find the ratio of the lengths of the corresponding sides of E, F, G, and H to A, B, C, and D. So first, tell me, are they similar? So set up your ratios and figure it out. Give it a try and bring this with you to class tomorrow. And that's all for this lesson.